this chapter, we will be looking at topics related to measurement. In this lesson, we will be learning to calculate the surface area of a cone, a cylinder, and a prism. We will begin by looking at the surface area of a cone.
Okay, so now we're going to take a look at cones, cylinders, and rectangular prisms here. We're going to find the surface area in particular here. So surface area is the amount of material needed to cover the outside of any shape. So it's that two-dimensional measure, like it's the amount that you can kind of feel, if you will. It's the part that you can touch, right? And I'm sure most of you are fairly comfortable with that idea of area. So, I mean, another way of thinking about it here is the amount of paper needed to wrap a present. That's actually a really good way of thinking about that. So we're going to start off with a cone. Okay? Now, a cone consists of two parts. What you've got is that lateral area here. And so if you think about it, like if we were to, normally what you would do here is you would take like a circular bit right here, cut it off so it's kind of like a Pac-Man here, and when you glue this and this together, it causes that conical shape to pop out here. And so this is the part that we're looking at here, that lateral surface area, the part of the cone. Like if it was an ice cream cone, that's the part of the cone that you're grabbing, right? That's the lateral part. Okay, and the part, that area right there, the formula for that is going to be pi rs. Now, just to be clear, and you can see it down here, pi obviously is pi. R is the radius of the circle that's formed at the base of the cone, okay? And S is the slant height. It's the distance from the vertex of the cone, the peak of the cone, down to that circle, that circular edge, I should say. Okay, that is our S here. And so it turns out that the surface area around the cone, the part that you would grab, is just pi rs. Then you got to consider the base of the cone, that circle, and the area of a circle is pi r squared. So, putting those together, we get that the total surface area of a cone is going to be pi rs, the lateral area, plus pi r squared, the bottom. Now, you got to be aware that in a lot of cases you aren't going to be given all of the information that you need immediately to plug information into this. Oftentimes you're going to have to use the Pythagorean theorem. Now, just to give you an illustration of what I mean, let's say you've got a cone here, okay? Oftentimes what will happen here is you will be given this distance right here, for example. Let's say that this is 3, and you'll know the height of the cone. Let's say that that's 4. But in order to figure out the surface area, it's not the height of the cone that I need, it's this distance along the side of the cone. This is our S. So now how do you figure that out? Well, you would use the Pythagorean theorem. 3 squared plus 4 squared is equal to S squared. And it shouldn't take you too long to figure out, S is equal to 5. And then I have enough information to figure out the surface area of that cone. Okay, so just bear in mind that sometimes you're going to have to use the Pythagorean theorem to figure out a piece of the information that you might not have. Now let's take a look at some examples. Alright, so our first question here says to determine the surface area of each cone to the nearest hundredth. Okay, whoa, this is fairly light here. What you're not seeing here is that this is 13 meters and this right here is 5 meters. Okay, now 13 I understand to be the slant height here. So the surface area at pi rs plus pi r squared is going to be pi, well, the radius of the circle at the bottom is 5. That's pretty straightforward. And in this case, we're giving you S as 13. And then we've already established that we know what the radius is. And so now, this is really just a matter of going to the calculator and plugging that all in. Okay, this will plug it in exactly as we see it. Pi times 5 times 13 plus pi times 5 squared. Press enter, and we'll do this to the nearest tenth here. We get 282.7. 282, oh sorry, whoops. Oh, I see, I got distracted. I looked there, it says to the nearest hundredth. So I was going to do that wrong. So it's going to be 282.74. So this will be 282.74 meters squared, whoops, to the nearest hundredth. Okay, there it is. It's as straightforward as that when you've been given the slant height. Now take a look at this one. In this case right here, we know, and again, it might not be 100% clear, that that radius at the bottom is 12, and the height here, just make that a little bigger, the height is 20. Okay, so now in order to figure out the surface area, I need the slant height, S. And so we know that 12 squared plus 20 squared will equal S squared. Okay, well, 12 squared is 144, 20 squared is going to be 400. Okay, that's going to be 544 is equal to S squared. Now, I'm going to end up doing this to the nearest hundredth, so I'm just going to write this as the square root of 544. Okay, so that is my slant height here. So now the area will be pi rs plus pi r squared. So pi, the radius we saw was 12, and then the slant height was the square root of 544 plus pi times 12 squared. Now I've got all the information, I just got to plug this into my calculator. Whoops. So this will be pi, whoops, times 12, whoops, times the square root of 544 plus pi times 12 squared. Okay, and we're going to get 1,331.68. 1,331.68 units squared. We never actually established what the units were over in the diagram, so that's about as good as that's going to get. There's your surface area. Okay, so this question says here that some paper cups are shaped like cones. How much paper to the nearest square centimeter is needed to make the cup? Okay, and again, if you can't see it here, this telling us that the radius here is 8 centimeters and that the depth here is 12. Okay? Now, this is an interesting question because in order to make the cone, I actually don't need that circle at the top here. And so this is one of the things that you're going to be required to do here. And this is why surface area tends to be a more complicated concept than volume. Okay? Because with surface area, you've typically got to piece together all of the different surfaces that make up a solid. Okay. Now with volume, it's just you just use the volume of that solid. I mean, you might have different kind of shapes put together, but you just do the volume of those pieces here. Here, it's very much the case where you're looking at the different surfaces and deciding whether or not you're including them. And in this case, we are not including that circle that would normally be at the base of the cone because that would actually plug up the cup. I do, however, need to know what my slant height is, and that's going to be 8 squared plus 12 squared. That is going to equal the slant height squared. And so 8 squared is going to be 64 plus 144 is going to equal x squared. And so we're going to get 208 is equal to s squared. And then I'll just take the square root of that, and it'll be the positive square root. I know that you could get a positive or a negative square root here, but it's got to be the positive square root. And I mean, I could simplify that, the radical here, but I'm going to be plugging this into the calculator in just a second, so I might as well just leave it as the square root of 208. My area, okay, the surface area of the part that I'm going to grab is simply going to be pi rs, in this case pi times 8 times the square root of 208. I don't need to add the circle because that actually isn't part of this particular shape here. So pi times, what was it? It was 8 times the square root of 208. Whoops. Sorry, I don't need that. Okay, and what does it say? To the nearest square centimeter, well, to the nearest square centimeter, that's 362 centimeters squared. You probably need a little bit more than that if you're going to tape it together and whatnot, but that's basically what the question is asking for. All right, so this question right here, this is a really good question. It's a really good assessment question because it's requiring that you go backwards with it. Actually, there's a few things in here, but mostly it's about doing undoing the algebraic steps to solve for a specific variable here. So in this case, we're given that the surface area of the cone below is 75.4 centimeters squared. And we want to determine the value of x, which in this case is the slant height here of the cone to the nearest tenth. Now when you take a look at the cone here, notice that we're given the radius here, but the radius is given in terms of millimeters, so we got to convert that to centimeters. And so 20 millimeters here, that's 2 centimeters. So now at least our units are consistent. And we know that area is equal to pi rs plus pi r squared. Now let's just plug in everything that we know. Well, we know that the area here is 75.4, pi times 2, and in this case they're using the variable x for that slant height, plus pi times 2 squared. Now, I simply need to get x here. So I've got two terms on the right hand side. I really needed to get it down to just this one term with the x in it. So I'm going to subtract that term that doesn't have the x in it. So minus pi times 2 squared is equal to pi times 2 times x. And now I've got these two coefficients in front of the x there. Okay, there are two factors, I should say, in terms of that coefficient. I'm just going to divide by that. So 75.4 minus pi times 2 squared over pi times 2. And that should give me x. Now it's just a matter of going to my calculator and plugging that in. So I'm going to put parentheses around the numerator because the numerator consists of two parts. So I want to make sure that I get everything in there. So it's going to be 75.4 minus pi r squared, or pi times 2 squared, divided by, and now because the denominator has two parts to it, it's pi times 2. Again, I need to put parentheses there. If I don't, then the calculator will divide by pi and then multiply the answer by 2. So I need to put parentheses there to tell it to divide by that whole thing. Press enter, and we get this beautiful little value here. Okay, x is equal to 10.0 centimeters. Okay, really, really good question. Something you should be prepared for on your assessments.
And now we'll introduce the formula for the surface area of a cylinder.
Now let's take a look at the surface area of a cylinder, which really consists of two parts. You got the two circles. Okay, you got the circle on the top and the circle on the bottom. And then there's this rectangular area that goes around the two circles. Now, if that's not immediately obvious, if you were to take the can here, let's say you popped off the lids, the top and the bottom of a can, and just made a cut right down the side, straight down the side, when you unfolded that, you would get a rectangle. And actually, I think if you think of that, if you were to take this thing and kind of roll it up, okay, you would see that rectangle there can become that circular shape or that cylindrical shape that we're looking for. So the total surface area of a cylinder then is going to be the area of the two circles plus the lateral area. By lateral, we mean side. Okay, the side area, which is that rectangle that we were just talking about here. And so 2 pi r squared, now just think about that. Pi r squared is the area of a circle, so 2 pi r squared is the two circles, top one and the bottom one. This one's a little less obvious until you really break it down here. H is the height. So if I come over to this guy right here, this is the height right there, that rectangle. Now, the other thing that we've got here is 2 pi r. Now, where do we recognize 2 pi r from? Well, 2 pi r is the circumference of a circle. Oh, so what they're saying here is that this top part here, if it's to be a cylinder, this top part here has to wrap all the way around. This distance here has to go all the way around that circle. So that means that this straight distance here has to be equivalent to the circumference of that circle, 2 pi r. And so there's why our surface area formula looks the way it does. Anyway, let's take a look at some examples now. All right, now this question says that the base circumference of a cylinder is 220 centimeters and its height is 63 centimeters. Find its total surface area. Okay, well, here we go. Here's our piece right here. Now, ideally, what I would have loved is to have had the radius, okay, because then I could have just plugged it into my formula, but I don't have that. I do, however, know the circumference. Now, the reason why that's significant is because, remember, in my formula, this was the circumference of the circle, so I don't even need to calculate that. I already know that that's 220. What I don't know, okay, what I don't know is what the radius is, and that's what I need to be looking for here. So 2 pi r is equal to the circumference, and right now 2 pi r is equal to 220. And so now to get my radius, I will divide both sides by 2 pi. Now, when I divide 220 by 2, I'm going to get 110. Dividing by pi is a little more awkward here. It requires the calculator, and I'm not going to do that right now. But there's my radius. So now I can go to my surface area. So my surface area is going to be 2 pi r squared plus 2 pi r h. So this will be 2 pi. Now r squared is going to be 110 over pi squared. And then 2 pi r, well, 2 pi r is 220. We already know that. That's the circumference of the circle. So 220 times h, which in this case was 63. Now, when I do this, when I put this together, I'm going to get 110 squared. Okay, and I'll just quickly go to my calculator. 110 squared is 12,100. So this will be 2 pi 12,100 over pi squared, because the pi in the denominator also got squared, plus 220 times 63, which is 13,860. Now, one of those pi's is going to cancel, and 2 times 12,100 will be 24,200 over pi plus 13,860. Now, without evaluating the pi or plugging in a number for pi, that is arguably about as simple as that's going to get. So what we'll do here is we will actually go to my calculator, 24,200 divide by pi plus 13,860, and I'm getting a surface area that is 21,563, now rounded to the nearest tenth, 0.1 centimeters squared. So it's approximately that value right there. Okay, there we go. Okay, so this question we read that the height of, we're supposed to find the height of the cylinder, the nearest tenth, if the cylinder has a radius of 6.5 centimeters and the surface area is 592.19 centimeters squared. So this is a case of us really just manipulating the equation here. Okay, so this is the surface area of a cylinder. Okay, we already know that the surface area is 592.19 centimeters squared. This will be 2 pi. We know that the radius is 6.5 centimeters squared. So this will be 2 times pi times 6.5 times h, our unknown. So I want to manipulate this equation to get my unknown. And this is something that we really need to make sure that everybody is capable of doing here. So there are two terms on the right-hand side of the equation. One of them has the h with it. I want to isolate that one, so I've got to get rid of this one. They are being added together, so I'm going to subtract that. So 592.19 minus 2 pi times 6.5 squared. I'll evaluate this all later when I use the calculator. So 2 pi 6.5 h. Now on the right hand side I've only got one term with that one variable in it. That's what I want to get by itself. So I am multiplying that variable by 2, by pi, by 6.5. Okay, now remember, when you've got a bunch of stuff multiplied together like this in a row here, they're all being multiplied together. Order doesn't matter. I can switch the order around however I want. So it's really just this whole bit here multiplied by h. So I'm going to divide everything by the 2 pi 6.5. So I will get 592.19 minus 2 pi times 6.5 squared. And that will all be divided by 2 times pi times 6.5. And that will give me my value for h. Now I'm going to go to my calculator. Now, I want you to see what I'm doing here, because it is frequently the case that when the mistake gets made, it's made because people don't really know how to use the calculator. Okay, there is this bar right here, which means division, but there's a little bit more to it than just that. That bar implies a set of brackets around the numerator and denominator, and if you don't put that bar there, you've done it wrong. Okay, so I've got to put parentheses around the 592.19 minus 2 times pi times 6.5 squared, and then I got to close that set of parentheses for the numerator, divided by, and I have to open them again for the numerator. If you don't open that set of parentheses for the denominator, then you're dividing by 2, and then you're going to multiply the numerator by pi times 6.5. A lot of times people have no idea. They don't even notice that the answer is really, really wrong. Okay? So please make sure you put parentheses around this. 2 times pi times, I think I'm off the screen now. Yeah. 6.5. Close brackets. And there we go. So to the nearest tenth, This is approximately 8.0 centimeters. Yeah, 7.9999 or whatever. So round to the nearest tenth, 8.0.
And finally, we'll look at how to find the surface area of a prism.
So now let's take a look at what constitutes the surface area of a rectangular prism. So it consists of three parts here. You're going to have the top, the bottom, and then the sides. Now, okay, so we've got the length, the width, and the height here. Now the bottom is going to be the area that's going to be the length times the width. It's this rectangle right there. Now that, bear in mind, that could be a square. This could be a square prism. In which case, actually, sorry, we're going to talk about that in just a second here. But so this will be length times width. There's going to be two of those exact same sides there. One at the bottom, one at the top. Then we're going to have the front face here, which will be length times height. And again, there will be two of those at the front and at the back. And then there's going to be a square or a rectangle here that's height times width. That's going to be from the right-hand side and then the left-hand side. Okay? And so what you get here is, yeah, length times width, there's two of those. Height times width, there's two of those. Length times height, there's two of those. And you have to put those all together. So, and when you do, you're going to get the surface area of a rectangular prism will be 2 times, oh, okay, a little bit of a whoops here. So 2 times length plus width, plus 2 times length times height, plus 2 times height times width is really what we wanted to say there. Okay, whoops. And that would be your formula for the surface area of a rectangular prism. Now, if it's a square prism, or a square prism, or a cube for that matter, what you're going to get here is that these are going to be the same here. Now, if it's a cube, oh, actually, sorry, this shouldn't say square prism. This should say really what they want here is a cube, surface area of a cube. If it's a cube, then each of those sides are exactly the same. So this would be like x, x, and then when you flip it over, it'd be x right here. And so what happens is the surface area of the cube would be 6 times x squared. Now, if it's a square prism, then what you've got here is you're going to have a square on the bottom, and then you're going to have these rectangles popping out. Rectangle, let's say rectangle, 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 and then you're going to have another square somewhere right there. Okay? So this is maybe, let's say, x, 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 and then this is going to be y. The length of each of these would be y here. And now the surface area, okay, would be 2x squared for a square prism, and then each one of those sides, and there would be 4 of them, they'd be exactly the same, will be x times y. Okay? So surface area of a cube is just going to be 6 times the side squared. Well, the surface area of a square prism would be 2x squared for the top and the bottom, the squares, and then 4xy for the lateral sides, or those rectangles that aren't squares there. You have to consider all of those. Let's take a look at a couple examples. Okay, so this question says, find the surface area of the following, and I can tell by looking at this that this is a rectangular prism because none of the dimensions are the same. There's nothing repeated here. So my surface area is going to be 2 length times width plus 2 length times height plus 2 height times width. Okay, so now I really have to just decide which of these counts as length, which one counts as width here, and which one counts as height. So maybe what I would do is 6 feet is the length, 3 would be the width, 2 would be the height. So this will be 2 times 6 times 3 plus 2 times 6 times 2 plus 2 times 2 times 3. Oops. And so what have we got here? 2 times 6 is 12, times 3 is 36. 2 times 6 is 12, plus 2 is 24. 2 times 2 is 4, times 3 is 12. And so 36 plus, well, what do we got here? I've got, these are all multiples of 12. I've got 3 of them here, 2 of them here, 1 of them here, that's 6. That's going to be 72. So 72 feet squared is the surface area of that rectangular prism. So in this question, we read that the surface area of a cube is 486 centimeters squared, and we determine the side length. Okay, well, the surface area of a cube was 6x squared, where x was the length of the side. So 486 is equal to 6x squared. So now I just got to solve for that x there. So first of all, I'm going to divide by 6, and when I do that, I'm going to get 81 is equal to x squared. And then I got to take the square root of both sides, so this is going to be the plus or minus square root of 81, which is going to be plus or minus 9, except that I know that the negative doesn't make any sense in this context, so it's just going to be 9 centimeters is going to be the length of the side. And that's all I really got to do. Let's now take a look at the assignment.